Hello grade 12s and welcome to the very last video in this series of videos on the November 2021 Physical Science Paper 2 exam. This video deals with question number 9, which is a continuation of the section on electrochemistry. Specifically here we are dealing with a question on an electrolytic cell. The question says, the diagram below shows a simplified electrolytic cell used to electroplate a ring. And we can clearly see that this is an electrolytic cell because it is connected to a power source, or rather as part of the cell, we have a power source. What is always important is to understand the context when you're dealing with an electrolytic cell. And here we would like to electroplate a ring, which means that we would like to form a thin layer of a specific metal on the ring. We see on the right-hand side pure chromium metal, which means that this electrode is made of pure chromium. In solution, we have chromium ions. They say that this is a concentrated solution of chromium ions. And we see on the left-hand side the ring. Now we know that we would like the chromium ions to be reduced at the ring so that they form chromium solid on the ring. The question is, how will these, or how can we ensure that the chromium ions in solution migrate towards the ring? The chromium ions are positively charged, and we know that positive charges are attracted to negative charges. So that means that the ring needs to be connected to the negative terminal of the battery so that these chromium ions in solution will migrate towards the ring. And that of course means that the pure chromium metal electrode is connected to the positive terminal of the battery. We remember the acronym RED CAT. So reduction takes place at the cathode, so this makes the ring the cathode. And we know that the other acronym is ANOX, which tells us that oxidation takes place at the anode. So we know that this pure chromium metal electrode is going to be the anode. I always begin by analyzing the problem as far as I possibly can. What I'm actually doing is brainstorming so that I remember everything that I need to know, so that when I read the questions, I don't become confused or overwhelmed. And I do suggest that if you're a learner who tends to get anxious as you write your papers, you do this as well. So let's now look at the actual questions. Question 9.1 says, define the term electrolyte. We can say that the electrolyte, or an electrolyte, is a substance whose aqueous solution contains ions. This will get us 2 marks. Or we can say it is a substance that dissolves in water to give a solution that conducts electricity. This answer can also get you 2 marks. We can say that it is a substance that forms ions in water or in melted. Or we can say it is a solution that conducts electricity. For any of these options, you will obtain your 2 marks for question 9.1. Question 9.2 says, is the pure chromium metal the anode or the cathode of the cell? Give a reason for your answer. Isn't this so nice? We have actually already answered this question by analyzing the problem. We said ANOX, oxidation takes place at the anode. So therefore the pure chromium metal is the anode. And the reason for this is because oxidation takes place at this metal. What is going to happen is that the chromium solid is going to be oxidized in order to form chromium ions. And that is the answer to this question. Since this question is out of 2 marks, you're going to obtain 1 mark for writing down the word anode and 1 mark for your reason. Oxidation takes place at the anode. Question 9.3 says, write down the half reaction that takes place at the ring. When we look at the ring, remember I mentioned to you that we would like to form pure chromium solid, a thin, a coating of pure chromium solid on the ring. So we know that the chromium ions are going to migrate towards the ring. They're going to gain electrons and they're going to be reduced to form chromium solid. So this over here is the reaction that we need to write down. We can show that the chromium ions are in solution while the chromium metal that forms is solid. For this answer, you're going to get your 2 marks provided that everything is correct, but it is actually not necessary for you to write down the phases of the reactant and product in this half reaction. You can leave the phases out, but I do suggest that while you practice, you write down the phases to see if you actually do know the phases that these compounds are in, because you may find that in one of your exams they do require you to write down the phases, and if you practice, then you know that you'll be able to answer that question completely. Question number 9.4 says, calculate the total charge transferred when the mass of the pure chromium changes by 2 grams. When we look at the half reaction that takes place at the pure chromium electrode, we simply have that the chromium solid is going to be oxidized to form Cr3+. These are the chromium ions plus 3 electrons. All right? So this is the formula. And we can see that the ratio of pure chromium to the number of electrons is 1 to 3. Charge is normally given the symbol Q. This is the symbol that we learned about in the physical science or the physics section. That is your paper 1 section on electrostatics, right? So we are incorporating, in a sense, electrostatics into a question on electrochemistry. So as a starting point, what we can do is we can calculate the number of moles of chromium in 2 grams of chromium metal. So we say number of moles of chromium is going to equal to the mass divided by the molar mass. That is going to equal to 2 divided by 52. The molar mass of chromium is 52, giving us an answer of 0.038 mole. Now we can use this number of mole to determine the number of mole of electrons. The ratio of chromium to electrons, as mentioned previously, is 1 to 3. So to determine the number of electrons, we are going to say 3 times 0.038, and this gives us that the number of mole of electrons is 0.115 mole. Now this is the number of mole of electrons. We are interested in the charge transferred. So now we need to determine the number of electrons transferred. We're going to use one of the formulas from the formula sheet, which says that the number of particles is equal to the number of moles multiplied by Avogadro's number. So this is going to be 0.115 multiplied by Avogadro's number. Remember, on your table of physical constants, this is table number 1, you're going to find Avogadro's number right at the bottom, and it is given as 6.02 times 10 to the power of 23. In the end, the number of electrons is going to equal to 6.946 times 10 to the power of 22 electrons. Given that we now know the number of electrons that, are going to be transferred, we can now determine the charge that is going to be transferred. You're not required to write out a formula as you would in your physics paper, but I'm going to write out that formula anyway. In the physics section, we found that the charge is going to equal to the number of electrons multiplied by the charge on an electron. So Q is equal to N multiplied by E. This N in the physics section was the number of electrons. So this number that we just worked out. The E value we know we can find in the table of physical constants. That is the charge on an electron given as negative 1,6 times 10 to the negative 19. So this is going to equal to 6,946 times 10 to the power of 22. We're going to take this and we're going to multiply it by the charge on an electron, which is negative 1,6 times 10 to the power of negative 19. When we multiply these values together using our calculators, we end up with 1113,85 coulomb as our final answer to this question. So there was a bit of physics involved in this question. If you would like, you can use just elementary charge instead and leave out the negative sign, but they did not specifically refer to current here, which is your positive charges moving in a circuit. They just referred to charge transferred, and that is why negative or positive, you will obtain the answer to be correct. This question is out of 5 marks. You will be awarded 1 mark for the method you used to calculate the number of moles of chromium atoms. 1 mark for the method that you used to calculate the number of mole of electrons. 1 mark for the method that you used to calculate the number of electrons transferred. 1 mark for multiplying the number of electrons by elementary charge, and 1 mark for your final answer, giving you the 5 marks for question 9.4. In the end, this question number 9, is out of 11 marks. And grade 12s, this brings us to the end of this question paper. Thank you so much for joining me. I hope that it was very helpful and that you will perform as well as you would like to in your paper 1 and paper 2 exam at the end of the year.